All right, so let's get into it. So for the polynomial below, 2 is a 0. Okay, right f of x is a product of linear factors. Very similar to the last topic we did in the preceding video. Probably the easiest way to do this one would be to start with the p over q thing. Because now, if the highest power of the variable was 2, we could go straight to quadratic formula, but it's not. So, all right, so our p's, they're going to be 1, 2, 3, 4, 6, 12. All the numbers that divide into 12. All right, that's a few. And our q's, well, the coefficient of our leading term is just 1. So just 1. That's nice. Okay, well, that kind of makes up for it. So our p over q numbers are going to just be all of these divided by 1, which is just all of these, but plus or minus. All right, so plus or minus 1, and 2, and 3, and 4, and 6, and 12. Cool. All right, no fractions. I can live with that. So let's go to the calculator and see what we can do. So I'll start by plugging in the function. Okay, so I've got the function in there. So let's go to the table again. I'll delete away all the old data. Where's that? There's that key. Okay, so let's start. It's probably only going to give us 1. That'll work, and that's fine. Okay, does 1 work? No. -1? No. 2? Yes. -2? No. 3? -3? 4? 6? -6? 12? 12. Okay, so just 2. 2 is the only guy that works. All right. So there's my button. So 2 is the only rational root, the only rational x-intercept. Okay, so that means I can write this as x minus 2 times stuff. That means I get to do more log division. Yay! Okay, so let's do it. So we'll divide x minus 2 into x cubed minus 8x squared plus 18x minus 12. All right, so I'll multiply by x squared and subtract. -6x squared. Bring down the next term again. 2 is a x-intercept, a root. Therefore, x minus that is a factor. Therefore, my remainder at the end of this division should be 0. All right, so let's multiply by -6x. And let's say plus 12x. Okay. We'll subtract and get 6x. Bring down the -12, multiply by 6. And I get 6x minus 12. Subtract. I do get 0. So everything's hunky and or dory. All right. So that means that this guy can be written as x minus 2 times x squared minus 6x plus 6. Cool. Okay, so we need to rewrite this guy as a couple of linear factors. So, we're looking for the zeros of the function, so we could set this factor equal to 0 and set this factor equal to 0. And when we set this one equal to 0, we get a quadratic equation. So we can do x equals -b plus or minus the square root of b squared minus 4ab C over 2A. All right, so we get 6 and 2. I always like doing those first because they're easy. And then 36 minus 24 gives us 12. And I cannot cancel anything yet because I got to pull something out of here because that's not 12. It's square root of 12. All right, so I can factor out a 4 and say, all right, the square root of 4 is 2. And now cancel a 2. And I get 3 plus or minus root 3. So if I write this as a product of linear factors, it's going to be x minus 2. So x minus one of the zeros times x minus another 0 times x, oh, whoops, I need another parentheses, times x minus another 0. And those inner parentheses right here, you can distribute those away if you want, it's fine. But that's how it works. But yeah, that would do it. And if you plug, hang on, let me change color so you can see. If you plug that in for y1 to your calculator, plug this big thing into y2, go to the table, you will find that they match, and then you should be doing that because it's an easy, fast way to check. All right, so now we're doing a lot more of the same, and notice it does specify this time we don't want decimal approximations, so you can't just grab them off the graph of the calculator, which would be cool. All righty, so let's go find our p's, which are going to be 1 and 3, our q's, which will be 1 and 5. So our p over q numbers are going to be 1, 1/5, well, plus or minus 1, plus or minus a 5th. Yeah, plus or minus 3 over 1, plus or minus 3 over 5. All right. Now we'll plug the function into the calculator, see which of these make the function equal 0. Okay, so I've got this guy here. So now I'm going to go to the table, hit delete a few times. Okay, then let's start plugging in numbers. All right, 1, no, -1, no. 1/5, yes, 1/5 works. I'll check the rest, though I don't expect any of them to work. Okay, 3, -3. Is that negative? Oh, 3/5. So 3/5 and -3/5. Okay, so 1/5 is the only one that works. All right, so that is good to know. So let's go back to here so I can, okay, so, and we're just finding the zeros of the function. We don't need to actually write it out the long way, but I'm going with all the factors, but whatever. So x minus 2 times some stuff, cool. And let me do some erasing. Whoops, that was supposed to be 1/5. Okay, all right, cool. So now we'll divide x minus a 5th into 5x cubed minus 11x squared plus 17x minus 3. All right, so I'll multiply by 5x squared and I get 5x cubed minus x squared. Oh, that's convenient. Subtract, and we get minus 10x squared. Bring down the 17x. And I'll multiply by 10x. Well, oh, wait. Minus 10x makes a difference. So I'll get minus 10x squared. 5s will cancel, and I get a plus and a 2x. I subtract, and I get 15x bring down the -3, multiply by a positive 15, get 15x -3. And I do get the remainder of 0, so I know I'm doing it okay. All right. So that tells me that it's 5x squared minus 10x plus 15. Okay, so there is a factored form. I don't need to write it in the factored form at the end, but I do, kind of need it for the moment. Okay, because I'm finding all the zeros. All right, I know one of the zeros is, oh, come on. What the, oh, must have hit the, okay, one of the zeros is x equals 1/5. Yeah, we already got it. What about the other two? Well, let's go find them. Okay, so when we set it all equal to 0, when we set this factor equal to 0, or go to the quadratic formula and get negative b plus or minus b squared minus 4 a c over 2, and I hope I'm doing this right. AC, okay, all right, so I'll get the 10 and the 10, which I cannot cancel yet. And then 100. And then what is that? That's going to be 60 times 5 is 300. Right. And, I got to be honest, I didn't even finish reading the name of this topic, but it says complex zeros. So, so that makes sense because we're going to get square root of a negative number there. Right, so we'll get 10 plus or minus root negative 200 over 10. Okay. Well, I could write it as, let's see, that negative sign becomes an I. I can do a square. I can do a 100 and a 2 because I know the square root of 100. Okay, so square root of 100 is 10. Square root of negative, oh, kind of jumped the gun there. I think we all knew what I meant, but that was supposed to be a negative 1. Okay, so square root of negative 1 is I. Square root of 2 is just square root of 2. And now I can cancel all of the 10s, actually. And I'm left with a 1 right there. Okay, so so my last two zeros of the function are going to be 1 plus or minus I root 2. So 1 plus I root 2 and 1 minus I root 2. And that is it.